Hi, Alan Stratton from woodturning. For this project, let's make this star. The background for this project is a couple of years ago, Theo from New Zealand did a presentation online, and I thought that was quite nice. I thought I'd try it. So I started to design the jig that he used, but to do it in 3D printing. That kind of put on the shelf for a while, and then Donna Frazier at SWAT gave me another kick in the rear saying, okay, well, it's time to actually do it. It does require a jig because once you've done your first turning, you do need to be able to hold the star so that you can continue turning them. And that's half the battle. In fact, in Theo's presentation, it was probably 3/4 of the presentation. The other key thing, though, is that both of them struggled with was defining the groove between the two. At one point I thought it might be a right angle. It's not. It depends on the diameter that you've chosen down here and the diameter that you've chosen down here and the taper between them. So it really helped me to have a little template to guide how far I'm cutting each time in the star creation process. So I will describe how you can do your own, plus I'll put the object file on this on a share site in case you have access to a 3D printer. So let's get with it and turn this star. Theo had precise measurements for his jig based on a 60mm cube. My primary measurement system is inches. I chose to make mine 2 inches. Actually, the jig cannot match the size of the cube exactly. I need some more wood in the length so that this can be mounted between centers when in use. A couple more inches on each end should work. Now would be a great time to mark exact centers on the ends, top and bottom sides of the wood. The ends will become positions for drive and live center. The top and the bottom are drill positions. Now it is time to drill a hole. I think Theo used 20mm. The exact size of the hole does not matter. However, this will be the center core of the star, so don't skimp. Mine worked out to be about 5/8. To do this, mount the board flat between the chuck jaws so that the drill can be used. Don't use a drill press because you will need this on the lathe in the next step. Next, taper from the 2-inch mark on the corners down to the corner of the hole at the 1-inch depth. Please note that on the top the hole will be larger than 2 inches in the middle of the board, 2 times the square root of 2 to be exact. Now flip the board over in the chuck jaws and to repeat the process on the opposite side of the jig board. I followed the same process logic in 3D design software. 3D design is the process of adding and subtracting, much like gluing on wood to add and turning off wood to subtract. In use, Theo's jig would have corners clipped during its first use. I went ahead and clipped them in software to keep the integrity of the 3D print. I also added threading to the ends for a more secure mount. Other than that, this is the same process, but translated to 3D. If you get a chance to see Theo demonstrate, it would be worth your time. From observing the two demos, both had issues measuring and cutting the V-groove. Following the same logic, I made a gauge. The width of the triangle base is 2 inches, the size of my cube. The height of the triangle is 1/2 my width, or 1 inch minus 1/2 of the drill diameter. The gauge was extremely useful in cutting my star, especially in the first and second turn. It was not as critical during the second and third because the jig also contributed guidance. Partway through, I found I needed to revise my gauge. My wood block is a 2-inch cube of laminated wood left over from another project. The best wood is dense and not prone to chipping. It is mounted between centers. Now, using a spindle gouge, I can cut a V-cut. I do not want to overcut, so I take it gradually and frequently measure it with my gauge. I have to sneak up on the corners to avoid rounding them over. This is a good practice in good entry cuts. As I frequently do in multi-axis projects, I sanded and applied finish at this point.
Here's where I realized that my first gauge was not deep enough. I had to quickly revise it. Then come back to the lathe and have another go at it. More careful cutting with the spindle gouge with frequent checks with the gauge. A little scraping with my skew, then sand and finish it all over again. Oh well, it was a learning experience. Now for the second mount. It is time to use the star jig. Mine is quite secure on threaded mounts on both the spindle and live center. Otherwise, with a wood jig, it takes almost 3 hands to mount. The jig cradles the wood in the previous cut. Other than that, the process is the same as the first cut. The gauge is handy, plus the edges of the jig add some more guidance. If you have to cut your own jig, you would be cutting into some of the jig corners and must rely on the gauge to know how far to cut. Sand and apply finish here again. Now for the third mount. Same cutting regimen, but be careful, since the star rays are now thin and fragile. If you cut your own jig, the corners are now rounded somewhat and can provide some guidance. I even used my jig for a bevel writing cut. My contrasting color helped, so you may want to stain yours. Even though all surfaces have been sanded and finished, my star had some chips on edges. Some additional sanding smoothed out the chips and softened these sharp edges. That completes my star. My only regret is sidelining this project for so long. I now have a nice star and a reusable jig and gauge to create more. One additional benefit is that by changing 2 parameters, inner diameter and cube size, I can make any size star that I want. If I cut into or wear out my jig, I will simply print another. I regard my 3D printer as another shop tool. Other than the threaded mounts, this took me about 60 lines of code, but at least a dozen test prints. Please give this video a thumbs up. Subscribe to my website because my notifications are more reliable than YouTube's. Please tell your friends about my weekly videos. I appreciate your comments and questions. Please wear your full face shield whenever the lathe is running. Are you wearing yours?